So let's begin working on section 6.6, exponential and log equations. After having spent a little bit of time with logs, now we're going to go back and look at how exponential functions and log functions are related and how they kind of work together in problems. So an exponential equation is an equation where we have a variable in the exponent. And we're going to learn two methods for solving this type of problem. Method one involves writing both sides of the equation with the same base. Then we set the exponents equal to each other. This method only works sometimes, so we're going to move on to method two after just a couple examples, because method two is way more important. But I think method one can really help you understand what's going on, so it's worth the trouble. And our first problem is to solve this equation, solve 2 to the x plus 3 equals 8 to the x power. So we want to solve for x. We want to find a value of x that will make the left-hand side of the equation equal to the right-hand side. And what's new for us in this problem is that the variable is up in the exponent. So if we want to apply method one here, we'd like to write both sides with the same base. I have base 2 on the left, I have base 8 on the right, but I know 8 is equal to 2 times 2 times 2. 8 is equal to 2 to the third. So I can rewrite that right-hand side of the equation as 2 to the third to the x power. And I'll recopy the left, 2 to the x plus 3. So that right-hand side, 2 to the third to the x, when I have a base raised to a power raised to another power, I multiply the exponents. So that's 2 to the 3 times x. And on the left, I still have 2 to the x plus 3. So notice here I got to the point where I have the same base, same base on both sides. So I have base 2 on each side. Now if I have the same base on both sides, 2 to a power on one side equals 2 to a power on the other side, then the exponents have to be equal to each other. So then we know that x plus 3, the exponent on one side, has to equal 3x, the exponent on the other side. The exponents must be equal. So we kind of plucked them out of the exponential position, and now we just solve for x using methods that we've learned a long time ago here. I think I'm going to leave 3 where it is, subtract x from both sides. 3 equals 2x. And I can divide both sides by 2, so 3 halves is equal to x. And that's my solution to that problem. Let's look at another one. And I got a little smudge here. There's a plus sign there. We're solving this equation, 27 times 3 to the 4x plus 1 equals 9 to the x minus 1 power. So a little bit more complicated, and I see different numbers as bases. If we're applying method 1, we're trying to get the same base throughout the equation, and you can probably see that 3 is the simplest base we have. If we could get base 3 everywhere, we'd have a good start on this one. So let's see, how can I rewrite 27? 27 is 9 times 3. 9 is 3 times 3. 27 is 3 times 3 times 3. It's 3 to the third power. I could say 3 to the third power times 3 to the 4 4x plus 1, just recopying, equals, now 9 is 3 squared, so that's 3 squared to the x minus 1. And I'm going to write that, both the 3 squared and that x minus 1 in parentheses. Because what I'm going to want to do is I want just one base on one side, one base on the other side. I need to get just one base and one base. On the left, because I'm taking 3 to the third times 3 to the 4x plus 1, when you have 3 to 1 power times 3 to another power, you can combine those into 1 with one base by adding the exponents. So on the left-hand side, I can write this as 3 to the 3 plus 4x plus 1 power by adding those exponents together. On the right-hand side, I have 3 to a power raised to another power, and the way I can rewrite that is as 3 to the product of those two exponents, one times another. I have to be careful about how I'm going to write that down. I want to take 2 times the quantity x minus 1. So I need to write 2 times x minus 1 in parentheses. And that may be the trickiest aspect of this whole process for this equation, just remembering to put the parentheses around x minus 1. It's because it's 2 times that quantity, x minus 1. Now I have the same base. And it's not just the fact that we have the same base. We have to have the base written once to a power equals the same base to a power. Then I know everything up in this exponent has to equal everything in the other exponent. So 3 plus 4x plus 1 equals 2 times x minus 1 in parentheses. And I'm going to go ahead and solve for x here. I can clean things up a little bit. I can combine like terms. I have 4x plus 4 on the left. I can distribute on the right. I have 2x minus 2. So the parentheses was crucial because that helped me see that I had to distribute the 2. And now to solve, I could subtract 2x from both sides. I get 2x on the left. I can subtract 4 from both sides. I get negative 6. I can divide both sides by 2. I get x equals negative 3. And that's my solution. So that's a couple problems where we applied method 1. In the next video, in part 2, we will apply method 2.